Greetings, building science enthusiasts, and welcome back to our podcast. This episode is brought to you by our dear friends and colleagues over at Risinger Homes. They're an Austin-based, full-service luxury home builder and remodeler, and we've worked with them on many occasions. And Risinger Homes really is a different kind of firm. First, they're focused on building science, which we think is incredibly important, and I encourage you to check out the YouTube channel of their owner, Matt Risinger. It's at youtube.com/user/Matt Risinger. Be sure to subscribe. And secondly, we've seen time and time again how much architects really appreciate the seamless experience of working with a builder who has an in-house architect/builder. Risinger Homes has exactly that person. His name's Eric Rouser. So architects, call Risinger Homes early in the design phase of your projects so we can team up with you and your client to build a great home.
Welcome to the Building Science Podcast. Welcome to the Building Science Podcast.
Bringing the human factor to construction, design, and architecture. Brought to you by Positive Energy in Austin, Texas.
Hello, everybody. Hello, and welcome back to the Building Science Podcast. I'm Kristof Irwin, here as always with my trusty sidekick, Miguel Walker.
Hello, everyone.
Today's episode is not an interview format. It's just going to be me and hopefully with some of you, Miguel. It's on resetting our collective vision for conditioned space. And what's motivating this is our direct experience on project team meetings and doing seminars, and just noticing that folks are due to recalibrate their expectations, to rethink their frames of reference, and to resort the relative priorities of the sometimes implicit or subconscious biases that we have when we're thinking about doing a design of a home or a building.
And if you've never actually had a vision for it in the first place, this is a great place for you to start.
Yeah. This is coming from direct experience, right? So we're an engineering team, and we sit around the table with project teams primarily somewhat constrained or pigeonholed to the role of, you talk to us about thermal comfort or mechanical system design. When in fact we're a building science consulting firm, as you guys know that are regular listeners, and we think broadly about conditioned space, and we really want deeply to understand the perspectives of all the stakeholders around the table. The owner's perspective, for long-term value and benefit to their clients, or if they're their owner on a home themselves, their family's needs. We want to make sure that we're aware of the artistic vision, the aesthetic vision, right? Beauty is so important in our world. We need as much of it as we can get. And also constructability, right? Structures, the lungs of the building, the indoor environmental quality, all these things are at play when we're making decisions early on. And what we're realizing, it's become clear that people on these project teams, there's two things about them, at least two things. One is that they are the implicit frontline advocates for the present possibility of delivering homes and buildings, right, to their clients. But they might not realize that. They might not understand that they're responsible for either advocating for the future or just acquiescing and somewhat unconsciously accepting the status quo as normal and as implicitly just fine the way things are. And you could really argue. I'd say there's smart people on both sides would say things really need to change and things are basically okay the way they are. When we think about it, roughly 90% of our lives are indoors in buildings, and roughly 70% of our lives are in our homes. So good grief, let's pay attention and make decisions that are informed by the present and where it's going, rather than just tradition and just the past. I think tradition is really needing to make way right now for transitions. So you guys are it's like Spider-Man here, with great power, meaning the power to influence owners or developers directly, comes great responsibility. So those of us that are sitting across the table from owners and developers, we really need to become aware of the lens through which we see our projects and the implicit distortions that can create.
But hopefully none of you have actually been bitten by a radioactive spider. Let's go ahead and lay that disclaimer out there now.
So so you guys have heard us say design around people, a good building follows, right? So if we expand the positive energy vision statement, it would be that one: design around people, a good building follows. Insist on a good building, an appropriate process follows. And for an industry process to change, perspectives must change. So this is where we're talking about, is that this show today is us endeavoring to find the reset button on project teams around the country. I guess I would say the first thing when you're looking for this reset button is, what is the upside? What is the tremendously unrealized upside, the potential of our built space? It is that built space could be designed around the occupants, and it could be delivered in a way that promotes efficiency and win-win for all the myriad players involved and all the myriad decisions involved. When we're making decisions about our projects, it might seem like we're making an architectural decision, something that impacts primarily aesthetics of a space. And primarily on that, it's going to be something related to aperture, probably. Orientation and massing are obviously very important, but we'll get back to that. But let's say you're making an aesthetic decision. It's one thing to make that decision just thinking about the art and thinking about the visual spatial impact of that decision. And it's very important, and there are myriad factors involved in that. It goes deep into our biology and our psychology. However, that same decision very well could be in fact impacting constructability. It could be impacting first cost. It could be impacting long-term durability of the building. It could be impacting the indoor environmental quality on many levels, probably primarily thermal comfort level in that application, or indoor air quality, right? If the apertures are allowing direct shortwave radiation to hit carpet or other surface loaded with VOCs. So resource and energy use are at play. Whether it's going to be a good long-term investment, life cycle costs, long-term costs of ownership, all this is at play. And it's very much like solving a Rubik's Cube or solving a Sudoku. And in that sense, what we're simply asking for, this reset button, is the first step is the aspiration to understand more dimensions beyond the aesthetic, right? Or let's say you're an engineer and you darn well need a high sidewall, double throw, double deflection diffuser to create comfort in this space. And yet you as well, we engineers, we need to keep some room for humility and learning and say, what is it that the architect is wanting to do here? What's the effect they're trying to achieve? And when you rest in that, chances are good you're going to have creativity and you're going to have a good idea. Whereas if you just say, look, I know how I've done this, I know how I'm going to do this, there can be this impasse. And frankly, just straight up, we sit around the project table and it's like the architect is braced for the mechanical designer to be in opposition, to have a sort of a confrontational viewpoint to what's needed. And we certainly try not to have that perspective. Now, there are some times where someone has created something that's tantamount to a solar oven in terms of orientation, aperture, and shading, and has said, yeah, and this is the master bedroom, right? And so first thing you would say, do your clients ever sleep late, right? Because it's going to get hot in here as soon as the sun comes out, and it's a radiative heating effect, so I can't just make the air cold enough to offset that, right? So there are some times where it would be great just to have the owner in the room and say, do you understand the trade-off here, right? If you love your connection to nature through your eyes, then understand that your connection to nature through your skin is going to be also intimate in that.
And part of what I hope that you're hearing is that this isn't the old school way of thinking about building science. We're not lost in the same bubble of a bunch of builders sitting around thinking about advanced framing or how they're actually going to spec the enclosure. Those things are very important. Mm-hmm. But when it comes to actually getting projects moving in a way that's meaningful and in a way that sets a standard that we can sort of trend the industry toward, it matters a whole lot what the client actually thinks about it and how they relate to it. So when you have an architect who knows how to advocate for good design practices and knows how to speak articulately to the client about what those decisions mean for the life of their home, for the quality of air that their family has, and for how the project is actually going to flow, suddenly cost can be factored into that in a different way than we're used to relating. You're not just quantifying specs on a plan set. You're talking about how the process is actually delivered. Mm-hmm. And that's a big deal and something that is inherent in using science to do it better.
That's exactly right. We really need to be mindful of when we sort of relax and let ourselves coast through particularly the beginning stages of a project, right? When that project's in programming and prior to SD, That's when it's malleable. That's when we can make our differences. And yet, from candid discussions with many architects over coffee and beer and lunch over the years, right? These projects go whoosh right through programming in SD, and they're in DD, because let's say the senior architect sketched something on the back of the napkin and it's a bit of a thou shalt design this moment, or this is what it should look like moment. The fact that it's one thing, it's a building, it's a mechanical system, it's a climate and its occupants, and it's all one thing, and please endeavor to see it that way. It's not just visual spatial. And, we've used the metaphors in the past. We'll touch on it again here. If someone brings you go to a fancy restaurant where it's, they're bringing you your food, and it's one of those, it's mostly plate with a little bit of lovely food in the middle, right? But what if it looked fantastic, and then you took a bite and you're like, oh, yuck. But, so here you go, you have this meal, and you have, it looked great, it's exactly what you want. And A, what if it didn't taste good? But B, and this is actually much more common, what if it actually is not nutritious? It doesn't provide fuel for your body, or worse, it provides anti-fuel for your body. It provides a burden to your body to deal with the grease and the fat and the salt and the sugar. So another way to think about the unrealized upside of our buildings is to think about the last, let's say 40 years, right? Think about the electric cars of the 1970s, right? Kit cars. You're listening to a guy that read a lot of Popular Mechanics. They even had kit helicopters and airplanes. But think about the Tesla versus 1970s cars. Think about the iPhone versus those heavy phones with, you put your finger in the wheel and you, or the TVs, right? Those big boxes that would go when they came on, and you could hear the static electricity crackle on the screen, versus flat screen ultra high def TVs today, right? So in consumer electronics and automobiles, our society is getting an amazing amount of technology transformed into products. Now think about 40 years of homes, right? Largely unchanged. What we've done is we have sought this one-to-one product replacement instead of a fundamental rethinking of the fundamental basis through which we approach the home, which could be, is it constructible? Is it beautiful on multiple dimensions at once? And does it serve the occupants and the owners? And not just with low first cost. It does serve them in that way currently. The two things I want to talk about now are the design process and the fundamental drivers to it that are in play through tradition. And they're sort of hidden, they're implicit, they might not be conscious. And they are that primarily, let's talk residential, right? This is our strength as a company, and it's our our mission, our sacred mission, to make homes more comfortable, right? This is where we all spend most of our time, in our residences, not in our places of work or commercial buildings. So it's important. But when it comes to homes, what we have been saying as a society to the people that deliver homes to us is primarily, how cheap can it be? Coupled with maybe how big can it be? And if you want to see this in spades, think about the mechanical systems, the air distribution systems, the heating, cooling, ventilation, dehumidification systems, and think about the average level of knowledge and expertise that most people on the project team don't actually have. Most people on the job site don't actually have. The average project manager in 2017 can absolutely talk to you about fluid applied control layers and myriad peel and sticks, vapor open, vapor closed, and ventilated roof assemblies, and ventilated rain screen assemblies. We can talk that way. We can oversee it. We can make it happen on our job sites. That same job site, someone will come in and install a fluid dynamically dysfunctional supply plenum right in plain sight, and no one catches it because no one knows. And when I say no one, I include, unfortunately, the hands of the installer that did the work. They're installing a plenum, a radial plenum usually, and they're doing what's always done, right? They're just doing what's always done, and it's just normal, and it like goes under the radar. It's like, of course, I'm going to do this plenum. And then you say to them, look, not in the first third, not in the middle third. Your takeoffs shouldn't be right across from each other. You should never have one on the downstream end of the plenum, never have one on the top of the plenum. You get into specific rules, and you get pushed back. And that's probably a whole other topic, the psychology of the industry that says, I would rather be pushing back on you trying to change my mind than be right or be open to new ideas. So that was the one idea, is that what we as a society have asked for from our homes, and particularly our air conditioning systems, is how cheap can it be, right? You do that for 70 years and look what you get. You get a fantastic low first cost type of system. The materials in the system are aligned with that. The expertise that's not needed to install those, right? So we can have interchangeable labor instead of, true craftsmen or guilds or long out the window. I have had the sun, I've been doing this for 30 years, given to me many, many times, right? It's like a bit of a euphemism or something, but it actually happens. It's not, I'm not just saying that, right? It actually happens. Son, I've been doing this for 30 years. I think I know what I'm talking about. So that's the person in the rowboat facing backwards, rowing the rowboat for 30 years. And every once in a while, someone in that boat needs to turn around and look forward. And when you look forward, what you're going to do is you're going to find out that there have been blind spots in your view, in your vision, and therefore in your mission and in your strategy and in your tactics. And one of the big blind spots in buildings, any of you that's in a building while listening right now, is this. It's the air that you are immersed in right now, right? Remember the joke about the fish? The old fish says to the young fish, hey, how's the water today? Swims off, and the young fish, one says to the other, what water? You are in a fishbowl right now. That's our strategy. We immerse our occupants in this fluid, and then we heat and cool the fluid, not the walls. We've talked about this before on radiant cooling. But what's in our fishbowl, right? Well, first of all, thousands of pounds of gases, right? When I say you're in something like a fish tank or a fishbowl, that's not just trying to make some poetic metaphor, right? You are in thousands of pounds of a fluid. It's a compressible fluid, but a fluid nonetheless. And just like in a fish tank, there can be little critters floating around you in the fluid. The walls of the tank can have algae, or we would call it mold. There's bioaerosols, there's ultrafines, there's PM 2.5, it's particulate matter 2.5 microns and less, 10 microns and less. There's all these categories to talk about the particles that are in there. There are myriad gas phase pollutants, not just VOCs, which are kind of like the poster child, but semi-volatile VOCs are arguably more impactful because their lifetimes are so long, the residencies. We have phthalates and bromated flame retardants. There are actually thousands of CECs that ASHRAE tracks, and those are contaminants of emerging concern. For every one, let's say phthalates, and let's say like 2 types of phthalates that have been extensively studied, there are actually thousands of other chemicals in this rich fish tank of an indoor environment that we don't even study, right? That's what's really scary. Add to this the indoor microbiome, right? We already mentioned bioaerosols. These are things like bacteria, viruses, protozoa, fungi, right? That's where mold comes in. Archaea, like actually little critters, dust mites. These glasses are not on our project teams when they're designing for aesthetic design, and they don't necessarily need to be the first thing, but you do need to understand when you're designing for a building that, let's make sure there's rooms for the lungs of the building. So we're going to talk about 2 topics now, and we're going to kind of dig in just briefly. And these topics, think of them as a lens or a window into the reality that we need to transition. We need to rethink the way we think about conditioned space. They're both hot topics. I want to touch on them, offer some ideas to ponder. I really don't want you guys to go and just swallow these ideas. I want you to reflect on them. Remembering that your clients come to you expecting you to be an advocate to help them spend their money wisely, right? It reminds me of T.S. Eliot has this beautiful quote. It says, "Where is the knowledge lost to information? Where is the wisdom lost to knowledge?" So the last thing we really want is for you and the rest of the project team to be awash in a sea of information trying to find knowledge and not even recognizing that wisdom can exist. So really think about these things. Make them your own, right? So that sounds pretty highfalutin and philosophical, which is okay with me. But today I'm going to talk about 2 topics as a lens into this paradigm. And that is aperture, so glazed apertures, windows, doors, and air distribution systems. So let's start with apertures. We've already talked about, and we've said it over and over on the podcast, that by the time the massing and the orientation and the aperture, where we're putting holes in our enclosure, are defined, you've basically carved in stone the energy use of that building. You know, it's not quite true, right? You can use efficient mechanicals, and you can coat the building with solar panels, and you can have wind generation for on-site power production. But in terms of the permanent physical attributes of the building, that's it. Massing, orientation, aperture, that's it. Once you build it, once you put it on the ground, it's very unlikely that it's going to be changed. There might be additions or something like that. First thing, when we talk about glazing, we need to talk about aesthetics. We need to talk about the psychology of connecting an indoor space with the outdoors. A building's connection to the outdoors, it stirs us deeply. It goes beyond the neocortex, right to our limbic system, and it makes us happy. It gives us an experience of satisfaction and of delight that is critical, right? Could you imagine a life where you have an experience of satisfaction and delight all the time while you're indoors? That'd be pretty cool. But frankly, what happens is we put so much glazing on our buildings that the only thing we can do to make people triggered or recognize that there's more glazing is to add even more glazing, right? So pretty soon you have floor-to-ceiling glass 30 foot long, right? And so obviously that's a huge connection to the outdoors. But at some point, somebody's lost touch with what is the ultimate goal here. Is it just to make a strong connection to the outside? Because if that's the main point, well, then your client could go outside. And I hope I don't sound irreverent there. So I really want to start with sincerity here and say that I understand that key view moments are very important, and positive energy and other human factor design adherence, we recognize that it's so important. But depending on the climate zone that you're building in, there may be unskillful strategies to glazing, right? And professionally, I'm waiting for the sort of the modern California look, especially in residential, to stop exporting itself out of Southern California, right? In Southern California, my in-laws live out there, and it's fantastic weather, right? Basically, they have very similar weather outdoors to what you want indoors. Probably, unless you're close to a freeway, the air quality is better. So that is a very different scenario than building in a hot, humid climate zone like Austin, Texas, or cold climate like Winnipeg. The point being that homes and buildings are highly functional, and they're, as well as aesthetic situations, they're energy and resource intensive devices that currently exist in a laggard state of understanding, I think.
We're not asking anyone to design a brutalist structure with no windows. We're just talking about the way we design glazing more sensibly.
What is glazing, right? Well, it is a material through which radiation, electromagnetic radiation from the sun can enter. In a heating-dominated climate, you want it to enter. In a cooling-dominated climate during the cooling season, you don't want it to enter. Glazing is amazing. Hey, does that almost rhyme?
Glazing is amazing.
Amazing glazing. I mean, truly, like what Cardinal's doing with low E366, right? So 3 layers of silver, that's what the 3 stands for, 66 visible transmittance. But look at what the U values are, right? They're like down into the range of 0.2s. The SHGCs, if you put the I-89 coating on, can get under 0.2. What I mean by that is these U values can approach an R value of 5, let's say. And the solar heat gain coefficient, we are getting fractional amounts of this electromagnetic radiation through. We're still getting a lot of energy through, even at a fractional amount, depending on how the overhangs are thought of. I went to a Passive House conference a few years ago, and an architect put up the word shading, and he said, "How many architects in the room?" And they raised their hand, and he said, "Okay, I want to introduce you to a word," and he had the phonetic definition of shading. And at the end, he and I were talking, and he said, I actually thought about putting the word wall up on the screen, because it's as though there's this aesthetic vernacular that says, what the best kind of wall is? It's all glass. What we want to say is that if thermal comfort is an important factor, indoor thermal comfort is very important, then we need to really think how that trade-off bumps up against my choice for where I put the apertures in the building and how I shade them and what kind of glass I choose, right? You can, by the way, you can get glass that goes up to above R10, I think R13 right now. That's expensive, right? Thermochromic glass, electrochromic glasses out there, variable VTs and variable SHGCs, U values. Glass is amazing. Think of it as a sophisticated multivariate solution just right there. The aperture itself, the shading of the aperture, and what you put in that aperture. That is a huge and permanent impact to the life of that building, to the resources and energy that are needed to maintain that building. So one more idea, and it is this, like, to the extent that you're not in Southern California, but you want this connection to nature to be profound and felt, maybe we want to have a room. This is actually, I will show you my biases, and this is thinking about a mechanical design approach to this. If there was one, let's say, giant room that was highly glazed, and it was able to be separated from the rest of the house, maybe like nano walls indoors or something like that, well, then I could deal with the load in that space very effectively with efficient mechanicals, and I wouldn't need to have that load permeate throughout the house, right, and fill the whole house. Like, so it's just an idea. It's coming from the perspective of, if you really want large window to floor area ratios, by the way, the code wants you to stop around 15%. We've had projects where on a given wall it's above 90% window to floor area, right? Excuse me, a given zone. So what we're thinking now is, let's make that highly glazed room its own zone and separate the heating and cooling requirements from the rest of the building. And there may be times of the day, like let's say mid-afternoon, where we recognize that there's going to be a different thermal comfort profile in that space, or we choose to just offset the heat gain through the glazing with lots of energy use, right? And lots of steady energy use for the life of the building. But what if we put in ceiling fans, we allowed the temperature to float, we had dedicated dehumidifiers, and we just said, during the heat of the afternoon, we expect the occupants to be on the other side of the house in this other beautiful room that has a highly glazed exposure, while this one is getting blasted with shortwave UV. So this is a mechanical engineer thinking about how to make beauty, but basically separate these highly glazed zones from the central core of the house might be a way to go about it. All right, so next thing is, and this one's probably a little more juicy because we as a company have really talked about this and we're a little more firm with it, and we're talking about air distribution systems right now. And then we'll wrap up. So first thing to remember is an air distribution system, your duct system, your plenums, your filter, your ducts, your runout, your diffusers, they're permanent, right? They're a permanent part of the home. It's like when you buy a car, imagine you only got one set of tires and they were only going to be inflated once, right? So wouldn't you want the right kind of tire, and wouldn't you want it to be at proper inflation, right? Instead, we have a culture where owners, a lot of the people on their project team, they're like, what kind of equipment can I have, right? So, and I love to talk about VRF, and I love to talk about DHU and ERVs. It's very important, and we will get back to that. Kind of classic mainstream building science. But more important than that is, I have one shot to do it right, and what is it that this system's needing to do? Well, let's talk about what an air distribution system does. I guess the main thing it does from a thermal comfort perspective is it moves a fluid, air typically, in order to accomplish thermal storage and exchange, right? So I'm moving the fluid. What does that mean? Let's look at that. Moving a fluid in order to accomplish thermal exchange. So first of all, I'm moving the fluid. So for the life of the building, I am going to be moving a fluid through a system that either has low resistance to fluid movement or high resistance to fluid movement. Again, think of the tires, right? If I never inflate my tires properly, well, the rolling resistance of those tires is going to be high, and I'm going to want to go fix them. When you design an air distribution system and it has high resistance to fluid movement, it has that forever. There is no fixing it. There was one good time to get it right, and currently today, just speaking very bluntly, no one's paying attention to it until it's too late to really do it right, right? So when we say we offer integrated mechanical design, one of the primary integrations is, how do the lungs of the building fit in with the architecture and the structure of the building? Very simple, very clear. So we're moving the fluid, we want low friction. It's a fluid. What does that mean? It means we paid for that fluid to have thermal energy in it that we want to exchange somewhere else in the space. So we don't want the distribution system to leak. This is a huge topic. So this is a fluid distribution system. It shouldn't leak. It doesn't need to leak. In many areas of the country, by many installers, it doesn't leak. It has leaks in the single cubic feet per minute level, right? We have installers here that can easily and routinely hit the 20s, 30s, 40 CFM of leakage. And then there's a whole crop of installers that basically say it's too hard, I can't do it, I can't get lower. But if you look, they've gotten lower progressively over time, over the past several years. They're arguing something that they're actually doing. They're accomplishing lower leakage. But this idea that fluid leakage, that basically that if your duct leakage isn't going to be obvious, and if it's going to have a subtle, pervasive effect over many years before a symptom shows up that a client will complain about or care about, right? These symptoms could be mold, they could be discomfort, they could be high energy use. As long as it's not flagrantly messed up at the beginning, a little bit of leakage is fine, right? That seems to be the mainstream view. Don't sweat it. But what does this mean, thermal fluid, right? It means, so I have a duct, and unfortunately, it's still probably in an attic, and I'm putting in cold air. I don't want that cold fluid, that cold air, to bump into the walls of the air distribution system. I'm putting it in on one end, and I want it to come out of the diffuser and enter the space on the other end with as little loss of that thermal quality that I've paid to give it, right? So the coldness that I've given it, I want it to go in and come out without bumping into the walls. To the extent it bumps into the walls, I mean, it's always going to have some bumping into the walls, but I can maximize or minimize that. And to the extent it bumps into the walls, I scrub away the coldness, right? So one of the reasons that an air conditioning system delivers 50, 55 degree air out of the diffuser, but it has upper 30s to low 40s at the beginning, is because we as an industry recognize, it's going to lose some heat. It's going to actually gain some heat in that scenario as it moves through the duct system. Now, in a heating climate, right, you've paid to create hot air. Hopefully you've paid to create it through a heat pump, but you paid to create the hot air, and it's going to be going through a duct system, and it's going to cool down. So I can minimize the cooling down by bringing the air distribution system into conditioned space. That's a big one. I can insulate better. I can air seal it better. But here's the one that doesn't get enough respect, and it is the actual shape of the air distribution system, the shape of the plenums, the design of the runouts, reducing trunk lines, all of these things, they're permanent, and you get one chance to do it right. And currently, there's two things happening. One is that chance is very much constrained because it happens after framing or late in the process. And two, there is really no design. There's mainly installation with a little tacit design because they have to install something. And the installation community, for various reasons, right? Like one of them being, for 70 years we've just said to them, how cheap can it be? They don't really take the time to be up on fluid dynamics. They know what's done, they know what's traditional, they know what doesn't flagrantly fail right away. Okay, I'm getting a little bit off to the side there. So we're distributing a thermal distribution fluid. So it's moving, so we want low friction. It's a fluid, we want it not to leak. It's a thermal fluid, so we want it to move through the system efficiently, low turbulence, right? Especially at the filter, we want low turbulence. So the other thing, and that's just why the first thing I said, it's permanent. It's permanent for the life of the home. Herein lies the big deal, right? And I'm going to say it, flex duct and duct board air distribution systems need to go away. In Austin, Texas, in 2017, they are considered a staple of the market. And there are people that are friends of mine, hardworking installers, builders, building science consultants, that could probably argue the other way. They could probably say, Kristof, the advances in new types of ductboard and the advances in different types of flex duct obviate, make your statement no longer valid, right? And I will say that there definitely have been advances, right? So pre-insulated rigid ducting is tremendous, right? It's also not cheap. But still, there's no way around it. If this is a permanent part of the building, and we look at what we just went through, let's look at sort of the characteristics of the duct system, right? So what do we want? Well, first thing is we want it to be a durable material because it's permanent, right? Second thing is we want it to have a very smooth surface. Hint, duct board does not have a smooth surface. Flex duct, unless it's pulled tight, the pressure liner, the inner pressure liner is pulled tight, and any turn over 30 degrees is accomplished with a metal fitting, then flex duct doesn't have that. Now, any of you that have seen a flex duct installation and can picture it in your mind's eye, right? You know that it's origami, and that go to Allison Bale's Energy Vanguard site and Google duct kraken. You'll see what I'm talking about here. So Durable material, smooth surface. We want it not to contain organic material, neither in itself nor should it be full of nooks and crannies that can trap organic material, right? Again, I'm talking about ductboard plenums. They can easily and do regularly trap dust. You put it in a cooling dominated climate like me, now I have dust and moisture from the coil blowing past forever, for the life of the home. I have this potential science project brewing. Last thing is, not only is it a durable material, ideally it's a recyclable material. This idea of cradle to cradle. We want to be able to reclaim the material and not just throw it in a landfill at the end. Durable material, smooth surface, recyclable, not full of nooks and crannies that trap dust, and one that can be designed to follow the principles of fluid dynamics and maintain them throughout the life of the building. And you can see that metal supply plenums, metal trunk lines, ideally reducing trunk and branch systems. And then the last thing is sound fluid dynamic principles have been followed. Which, by the way, the ACA manuals, manual D and T, D for air distribution systems design, T for terminal devices. Those are somewhat highly simplified, or at least simplified, concepts and metrics associated with proper fluid dynamics principles. And they're largely not adhered to. They're not largely not known about, right? Some people know about manual J, and then people know about manual S, and you get down to manual D and T and it starts to fall away what people know about. The fact that these accepted principles aren't followed is very clear. It's in plain sight, right? I'm one of these guys, right? When I go to a restaurant or an ice rink, I'm always, if there's a visible duct system, I'm looking at it, right? So here we are. All you have to do, a crowd of 10,000 people at the ice rink, you can look up and you can see fluid dynamic principles violated over your head. And at job sites, right? We were on project where the job site is immaculate. It is run with precision, and there's Gantt charts posted everywhere, and it's amazing. And I mean this truly. My hat is off to these builders, GCs, project managers. It's tremendous what they're pulling off. And it would be nice, it'll be even more tremendous when what they're pulling off includes effective oversight of the air distribution systems. I'm going to touch back in on the fact that there's no like bad actor maliciously out to get us going, I've got a bad duct system in your house. There's us. There's all of us on project teams that don't advocate effectively and or don't populate ourselves with the proper perspective, right? We're just, this implicit assumption that everything's fine, especially with air conditioning systems, is something that your clients have in their head. And if you don't correct it, that's a potential damage to your brand and for the future strength of your company, because what's happening is the general public is becoming much, much more aware about health, comfort, and well-being, and they are learning now, they will continue to learn about the overlap of the health sciences and the building sciences. And it is not too early for all of us to understand that that's an emerging trend in society, almost like a cultural shift. So let's summarize. A home or a building is a highly functional space. What do we put into it, right? Well, we put resources and energy to cause it to exist. We bring in electricity, clean water, gas, hopefully only for cooking. We bring in data, Google Fiber or cable connection. That's a very important input. And then we put in clean air, hopefully clean, dry, comfortable air, and maintain it with our enclosure. And then we put in the occupants. When we put in the occupants, there it is. There's the ka-ching moment. What is the output of the building? What is the output of the home? The output of the home should be recognized. The goal should be healthy, happy, productive families, members of our society, members of our economy. To the extent that you're all drugged up on some allergy medication or you didn't sleep well last night, right? That impacts, you think that just impacts you? It impacts everyone around you. It impacts your employer. So that's a very important perspective, that these buildings are serving society in a very tangible way. The last thing I'd like to do as a wrap up is just talk a little bit about these broader transitions. So what we talked about today was basically our aspirations as professionals in this industry. To what level of beauty, of multidimensional beauty, do we seek to attain, right? What is our goal? What is our view and our understanding of the upside potential of a building? How do we communicate that? Straight up, this podcast was started because Miguel and I are doing a lot of seminars, a lot of public talks and project team meetings. When we start talking about indoor air quality or thermal comfort, it's like I'm Chicken Little and somehow I'm just running around fear-mongering and trying to freak people out. And I really have a struggle how to work with that. Today's episode is about trying to hit reset and make it so that that message is actually received like, yeah, there is something there. Anyone on your project any of the owners, let's say, that would go to the grocery store and buy organic spinach or organic kale or something like that, they are evidencing the same value preference system that would have them care deeply about their air distribution system, the particles, particulate catchment system, the gas phase pollutants that'll be in their home, and yet they assume everything's fine. I'm telling you it's not. As a tradition, what we've inherited since Levittown was a segmented process, a baton pass from the architect to the GC to the installer to the owner, right? We have lost our guilds, we have lost our craftsmen, we have sought interchangeability of relatively low skilled, therefore exploitable, interchangeable labor. We are relying on standardized materials, cheap standardized materials. We love product-to-product replacements, especially when one product is supposedly better and cheaper. That's the best, right? So again, both of those, interchangeability of labor and standardized materials, low first cost optimization. This focus on form over function, enough. We don't do that in other areas of our economy. Let's stop doing it with our buildings and our homes. This occupants as science projects, right? Well, let's put this bromated flame retardant into the mattresses and see what happens. See if it does impact the endocrine system. Oh, it does. Oh, well, too late. It's already in there, right? Chloridane, asbestos, formaldehyde, endocrine disrupting chemicals of all types. We don't have to put them in our buildings, but if we don't know that they're a problem and we don't know what is in the materials we are choosing, and I'm talking paints and sealants. So that's the tradition. That's what we're coming out of. What's the transition that we're heading toward, right? The big one is going to be this human-factored building science, where the science of putting the occupants in matters. It is also going to be the systems theory that architects and many people refer to as integrated project delivery, right? That is a systems approach to delivering a building, and it goes through construction administration, post-occupancy evaluation, even retro commissioning, right? So the process, integrated project delivery as the norm instead of the lauded exception, is where we're going. I would like to see us phase out combustion generally, right? Combustion, and I mean gas. It's an exergy disaster. Why do I need 3,500 degree flame to heat water to 120 degrees or air to 70, 75 degrees, right? We should stop. We are at a point where we can be very judicious and in many climates eliminate compression. We don't need energy hogging compressors, right? I won't go much deeper into that. We want low thermal flux density enclosures, less than 10 BTUs per hour per square foot per year. If that kind of seems gobbledygookish, it doesn't to someone on the project team. Ask them how your project is measuring up on thermal flux density. Climate zone appropriate enclosures. This is the big joke, right? John Straub is a tremendous building science luminary and a great guy, and he has just one of the most sardonic, kind of catching humor that I love. And he shows this picture of glass skyscrapers in downtown Honolulu and downtown Austin and Winnipeg and Toronto and Beijing. And he says, apparently glass skyscrapers is the one climate zone appropriate enclosure that works everywhere. So climate zone appropriate enclosures, we need to think about occupant conditioning instead of just air conditioning, right? And we need to stop thinking of air conditioning as air cooling. When we condition the air, we got to think of, what does that mean? I'm conditioning it for occupancy. And then once all those are done, that's the time to think about integrated renewables and storage, right? I'm really happy to have, like, for instance, Elon Musk getting in with the solar roof tiles, right? So fantastic. I from a professional engineering standpoint, I think of it as bling, and I think of it as far down the food chain. You should not put those solar tiles on your roof until you're paying attention to indoor environmental quality, indoor air quality, air distribution, a low thermal flux density enclosure. Otherwise, you've just capitulated. Design around people, a good building follows. Insist on a good building, an appropriate process follows. For an industry process to change, perspectives must change. So thank you for listening. Thank you for keeping your mind open, and hopefully your perspective can be something that you put into your contemplation going forward.
Thanks so much for listening, guys. And please don't forget to check us out on our website at positiveenergy.pro. If you like what you heard today, if you hated it, we want to hear about it. We want to know more about you. And don't forget to subscribe and let your friends know. Thanks so much.